All right, when researchers look at unbiased samples, stop talking when I am talking. When researchers look at unbiased sample sizes and apply it to the population, they're 95% certain that the results are within the margin of error from their percentage. Have you ever watched, like, when the election results come in, or when they're doing polls before the election comes in, they say there's a margin of error of plus or minus 2%. Okay, this candidate has 58% support, and there's a margin of error plus or minus 2%. So that means they're 95% certain that the true percentage is between 56 and 60%. It could be a range there. Okay, there could be a range there. So you take your percentage, you subtract the margin of error, you take the percentage, and you add the margin of error. So the first example there says candidate Kesters has a 76% approval rating with a 6% margin of error. The bigger the margin of error, the less certain they are of the results, so to speak. Because that really means it could range anywhere from 70% to 82%. Okay? They're 95% certain that Kesters has an approval rating between 70% and 82%. That's what the margin of error means. Okay? Senator Smith and Miller are in a close election. Senator Smith is projected to get 52% of the vote with a 5% margin of error. So the highest amount that Smith is projected to get, we add the margin of error there, so it's 57%. The smallest amount is 47%. So it looks like originally, if they just tell you he's projected to get 52% of the vote, you think, okay, he's going to win the election, right? He's got more than half. He's going to win the election. But that 5% margin of error, the lower end, that puts him below half. Okay, so he may not actually win that election because he could get less than half of the votes. Okay, C says, what's the highest amount of the vote that Miller is projected to get? So his highest amount would come from Smith getting his lowest amount. So Smith's lowest amount is 47%. So in that case, the highest Miller could get is 53%. Okay, the highest Miller could get is 53%. All right, let's look at example 3. Flip the paper over. The percentage of people who speed through a town is between 35% and 43%. Find the mean percentage of people who speed and the margin of error. So we've got the low and the high. The mean is right in between. So you add them together and divide by 2 is one way to do it. Okay, add them together and divide by 2, and you get that the mean is 39. Or they looked at it from the perspective of, okay, I have a range of 8% right here. Well, half of that's going to be on one side, half of it's going to be the other side, so the margin of error is 4, and so 39 would be right in the middle of that. Okay. Sometimes they won't give you the margin of error. Sometimes you will have to calculate the margin of error. I really honestly don't think that they're going to make you do this on the final exam, but I did want to show it to you. This is the formula for determining the margin of error. Your margin of error will be smaller when N is the number of people. That's how many people you're surveying or whatever. So when this is bigger, you're going to have a smaller margin of error. That's always going to be the case. With the more people you have involved in the survey, the smaller your margin of error, because that's going to make that a smaller number, okay? So example 4 there asks you to find the margin of error. In a poll of 150 students, 78% said that they enjoyed their teachers this year. So 150 students is the number, it's N, 78%. So we have to express that as a decimal. We move it to 0.78. We plug it into our equation here, and we get the margin of error is 6.7%. Okay, so we would add that and subtract it to get our certainty statement. Okay.